Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, episode 22 of 24. When your autonomous agent goes on a 50-step reasoning loop, how do you track the bill back to the original request? If the agent makes dozens of isolated calls to different language models, your billing logs become an unreadable mess of disconnected requests. The solution to this is the LiteLLM Agent Gateway, also known as the A2A Protocol. Before exploring the mechanics, we should clear up a common confusion. Listeners often mix this up with the Model Context Protocol, or MCP. MCP is used to provide external tools to a language model. A2A does the exact opposite. It treats an external autonomous agent as if it were a standard language model, allowing you to invoke it and track it through a centralized gateway. To set this up, you define your agent in the LiteLLM configuration file exactly as you would define a standard language model. You give the model a name, set the base URL pointing to your agent API endpoint, and specify the provider as a custom OpenAI endpoint. Now, LiteLLM knows how to route incoming client requests directly to your agent. When a client sends a request asking for this agent, LiteLLM acts as a pass-through for context headers. It takes the metadata tied to the request, like user identifiers, team routing tags, and budget limits, and packages them into specific HTTP headers. The most important of these is the LiteLLM Trace ID header. LiteLLM forwards these headers along with the prompt to your agent. Here is the key insight. Your agent receives this request, starts its autonomous loop, and begins making its own internal calls to process the task. If the agent makes these calls directly to a public provider, you lose the tracking context. Instead, the agent must route its internal calls back through LiteLLM. When it does this, it must include the trace ID it received in the original request. Consider a concrete scenario. You're invoking a local LangGraph agent. A client sends a prompt through LiteLLM to start the process. LiteLLM assigns a unique trace ID and forwards the payload to the LangGraph endpoint. Your LangGraph application reads the incoming HTTP headers and extracts the LiteLLM trace ID. When LangGraph needs to evaluate a step or summarize data, it uses its internal client to send a completion call back to LiteLLM. Crucially, it attaches that exact same trace ID header to its outgoing request. Because every internal call carries the same trace identifier, LiteLLM groups them together automatically. When you look at your observability platform or budget logs, you do not see 50 random requests from unknown sources. You see one unified trace. You know exactly which user triggered the agent, how much the entire reasoning loop cost, and which specific autonomous steps consumed the most budget. Treating agents as standard model endpoints transforms complex multi-step agent workflows into trackable, billable units of compute. Thanks for listening. Happy coding, everyone.